so I am looking at, in the packet, on, I have page 3 here, but I'm not sure if it's on 3 or not. Yeah? Oh, great, it's on page 3. What was it? Second page of the packet. I want to look at this one first. Number 1. So what does it say under that picture? What kind of forces are they? Concurrent. We already know that, right? Why are they concurrent forces? What was that? They're all acting on the same point, right? Have you ever heard them? Yeah.
I'm just wondering if the example there are questions like that.
Yes, but right now we're starting, so it's definitely on concurrent, because this is what we've done already, okay? But once I move after that, we're finished with the first section of the course. Okay, but yeah, vocabulary, yeah, you need to know vocabulary. Okay, because you need to know how to speak as an engineer. So this stuff is still up for grabs on the first exam. Okay, so did you ever hear the term point load? Point load? A load acting on a point? Or how about concentrated load? Heard that term? Okay. So what we're looking at here is when you have one force that's acting on a point, you could call it a point load. And you could also call it a concentrated load. And what the deal is that the force is concentrated on one point. So right now I have my weight going down, and if we wanted to draw a force with my weight, we would draw one line with one arrow going down, right? Is that a point load? Yes, all my weight is on one point. Is it a concentrated load? Yes, my whole load, my whole weight is concentrated on one point. So when we look at this with concurrent forces, are these considered point loads? This one's labeled F1, F2, F3, F4. Are they considered point loads? Yes, because they're all located at one point. Okay. What about, are they concentrated loads? Yes, they are, because each one of these forces, F1 is concentrated. Whatever that force happens to be, we really don't know what it is. It could be like an elephant out here tied to this thing. We have no idea. But the whole load is concentrated on acting on one point right here. Yeah, Charlie?
So is there any difference between the two?
Nope, they're the same. The term point load and concentrated load are synonyms. Synonyms. Okay? So if something's a point load, it's a concentrated load. How about some of the other forces we know? Normal, something sitting on a surface. My foot's on a surface. There's a normal coming up. Is that a point load? Yes, because it's drawn with an arrow, with a line and an arrow. That's a point load. Is a normal a concentrated load? Yes. What are some other forces we know? Normal, tension. How about tension? Is tension a point load? Yes. Is tension a concentrated load? Yes, they're both the same. If it's one, it's the other. So we have weight, we have tension, we have friction. Is friction a point load? Yes. It's one arrow, one line with an arrow pointing in a certain direction. It's a point load. Okay? It does slide, it is along a surface, but it's still defined by by a point load. Because loads are one of two. They are either point loads, which we are also calling concentrated loads, or they are distributed loads. This is the other option. Distributed loads. And for those that took materials, you learned about stress, right? If I have an area, and I don't mean stress in your head. If you have an area here, you have an area, and you have a load on here, my load, the load is spread out. My load is spread out, or the correct word is the load is distributed. That's not right. Distributed over. In this case, what is the load distributed over? An area. And remember stress, which is sigma, lowercase sigma. You know the Greek symbols have uppercase and lowercase. This is lowercase sigma. Stress is, how do I calculate stress? It's the force that's applied over the area. So loads, forces, another forces or loads, they're synonyms. They're either point loads or they are distributed loads. So if it's one or the other, right here I took this whole force and I applied it right at this point. F2, F3, F4, all of them are loads that are acting at one point. So all of them are point loads and they all are concentrated loads. Tim?
So for your normal force, isn't your normal being compressed through the sole of your shoe, which is an area?
Yes, that's true, but then we take it and we analyze it as only a force. So it depends on, okay, let's think of snowshoes, right? There's a lot of snow up in the mountains. Now, has anybody been to the snow yet? Lucky. Okay, so you're walking in 2 feet of snow, right? And you step down and you crunch through the upper thing and you go down. Then you decide, okay, I'm going to try snowshoes, and you put snowshoes on and you walk, and you're not going down anymore. What did you change? You changed the area, right? Because my weight's still the same, right? In the first case, my weight